Hello and welcome to another video of Vivek Learns. So, in this video series, we are trying to solve the level 1 of PepCoding, and the last problem that we had solved was reverse a number, where we were given a number and we have to create a number which was reversed of the given number. Like if we have 1, 2, 3, then the reverse number is 3, 2, 1, and we had to print the reverse number. So that was the last problem that we had solved. So let's continue this series by solving the next problem, which is inverse of a number. Okay, so let's first understand what is inverse of a number. You are given a number following certain constraints. The key constraint is if the number is 5 digit long, it will contain all the digits from 1 to 5 without missing any and without repeating any. Example 23415 is a 5-digit long number containing all digits from 1 to 5 without missing and repeating any digit from 1 to 5. Okay, take a look at few other valid numbers. 62315, so it is a 6-digit number and it contains all the 6 digits from 1 to 6. Similar is the case with this number. Let's see some of the invalid numbers which are 139. Okay, it is a 3-digit number but it contains 9 and so on. The inverse of the number is defined as the number created by interchanging the face value and the index of digits of number. Example 426135. Reading from left to right, 5 is in the place of 1, 3 is in the place of 2, and 1 is in the place of 3, 6 is in the place of 4, 2 is in the place of 5, 4 is in the place of 6. The inverse will be 416253. Reading from right to left, 3 is in the place of 1, 5 is in the place of 2, and so on. More examples like this. Okay, take as input number n, assume the number will follow constraints. Print its inverse. Okay, so let's first understand what is inverse, right? So we are given a number and it is a 4-digit number, so it will contain all the digits from 1 to 4, and all the numbers will be present 1 as well as they will not repeat themselves, right? So let's write the face value of these number. So the face value of 2 is 4, the face value of 3 is 1, that of 3 is 2, and that of 4 is 1. So the inverse of this number will be, okay, let me write the inverse here. So now what will happen is that 4 will go to the first place value, right? Okay, so 1, sorry, my bad. 1 will go to the first place value, right? For the fourth place value, not the one. Okay, so 1. Okay, now 2 will go to the third place value. Okay, let's write 2 here. And 3 will go to the first place value. So we have the first place value here, right? And 4 will go to the second place value. Let's check if our understanding is correct. So the inverse of 1, 2, 1, 3, 4 is 1, 2, 4, 3. 1, 2, 4, 3. That's right. So let's try to code this. Um, how will we code it, right? So what we can do is that we can have the numbers and we can iterate over this number and have each digit printed, right? Like 4, 3, 1 and 2, right? And now, like we had seen a similar problem, like print the digits of a number, right? But what do we want now? We want 1 into 10 to the power 4, right? Something like this. And then we want 2 into 10 to the power 3. And then we want 1 into, 3, right? 3 into 10 to the power 1. Then we want 2 to 10 to the power 2, right? And then what do we want to do? We want to add all these numbers. So what will we get the output as? 1 into 10 to the power is 1, 2, and then 2 into 10 to the power 2 is, sorry, my bad. 4 into 10 to the power is 4 and then 3. Okay. So we'll have a variable called digit, and it will start from 1 to that particular to the digits present in the particular number. And what we do is we get the digit from the number and we do math dot power 10 to the power that particular digit that we get from last to first. Okay, so let's try to code that now. This is similar one, so let me name it inverse of a number. Okay, we take a number and we also take a variable called, let's say, digit. Let's not call it digit, let's call it as count. So count will start from 1 and it will keep on increasing till the digits of the number, right? So inverse num is equals to we have to increment the count for each iteration. And we'll print the inverse num. Okay, so let's try to run this. We'll take this sample input. Oops, something went wrong. Okay, let's try to figure out what is wrong. Reversed number, so first we get the number and 10 to the power, oh sorry, my bad, where have you the digit that we got? So we have to multiply that digit also, right? What we do is that we multiply the digit with 10 to power the count, right? Oh sorry, what we do is we have count times that, right? Yes. So count will be 1 first. So 1 times 10 to the bar, the digit what that we get. Let me run this again. Hopefully we get, oops, my bad. 73468 last. 681 is left. Okay. Okay, so what we need to do is 10 to the power 4 minus 1, right? Mm, yeah, yep. So what we need to do is we need to have digit minus 1, right? Yep, that is what the output that we are expecting. So let's go to the problem once, right? We have a number 4321. What we did was we got the digit, each digit of that, of okay, let's consider this number, right? Like we had this number 2134. What we did was we got each of the digit of the number, and what we did was we had a counter called count, which is 1, and what we did was we multiplied 1 with 10 to the power the digit that we get minus 1. Similarly, we have done, we got the second digit, just 3 now. We multiplied 2 into 10 to the power the digit that we got minus 1. Okay, and we followed the similar steps for all the other remaining digits. Okay, so 1 2 3 4 is because we have 4 digits, and uh, this, what you see in the brackets, is the digit that we get. Okay, so that was it about this problem. Let's go to the next one, which is rotate a number. You are given two numbers, n and k. You are required to rotate n k times to the right. If k is positive, rotate to the right, that is, remove the rightmost digit and make it the leftmost to the reverse for negative value of k. Also, k can have an absolute value larger than the number of digits in n. Take input n and k, print the rotated number. Assume the number of rotations will not cause leading uh, zero zeros in the result. Example, such inputs will be, okay, okay. So we'll be given two numbers, like let's assume this is the number, and we have to rotate it 2 times. So what will happen? These two digits will be rotated. These two digits will be hmm, will come to the left. Like 84 will come to the left, right? Okay. So how do we solve this question? Let's try to analyze this. So what we can do first is we can have mod of 10 to the power 2 and we can get these two numbers first, right? We'll get 84. Okay. And what do we do after we get 84? We What we can do is that we can have the count of digits minus mm, the count of these digits and multiply with those, but minus k, right? K is nothing but the times that we have encountered this, yeah. And then we can multiply that number. So what is the count of digits here? 1, 2, 3, 4, 5, 6. 6 minus 2 is 4. So we can have 4 zeros here plus 5, 6, 2, 9. Okay, 5, 6, 2, 9. So what will be the output which we get? 8, 4, 5, 6, 2, 9, right? That is what we expect, right? So what we'll do is that we will first count the number of digits and we'll keep it in a digit count variable. And what we do is next we get the digit count minus k. We multiply by the digits that we get by taking the modulus, and then we add to the number that we have, right? Okay, so let's try to do this. Let's create a class called rotate number. Yep. Enter a number, enter times to rotate it. Then we have a digit count number, right, which is 0 first. Then we iterate over that number, and what do we do? First we'll calculate the digits of the number. Okay, once we have calculated the digits of the number, then we form the new rotated number. Okay, so we would have lost the number by here, like the number will be 0. So let's put the number in some temporary variable. Once we put it, we can, what we can do? Yep, we can have the temp num, so temp num mod k, mod the times, right? So this will give us the trailing numbers, and let's have this as what do we call these? Mod num. Okay, and the temp num. So what are we doing here? Mod num is nothing but the digits that we get after we do the modulus. So I do the mod 100, so I get 84. So mod num will contain 84, and then temp num is equals to temp num divided by times. So what will be the number now? It will be, we have removed these last two digits, so it will be 5629, right? Yep, that's right. Yeah, so we have done this. Now what do we do? Rotated number plus, we can have it directly here, right? Int rotated number is equals to, what we can have is mod num times int of math dot power 10 to the power digit count minus times plus the number that we have, temp num, right? Let's try to print it first. Mm, let's try to run it once for a positive scenario. Remember, a k can be negative also, like we are not considering that in this scenario, but let's keep it, let's think about it after we pass this test case, right? Okay, I think it's going into an infinite loop here, right? And I know where it is going. Like we haven't reduced the num here, right? Num is equals to num by 10 I copy num. Rotated number is 281429, which is wrong, right? Okay, so what we have to do is mod num times 10 to the power digit count minus times plus temp. What is mod num? Mod num is, oh, times, my bad. We have to do math dot power 10 to the power times, right? And we'll have to do the similar for this also, right? When we are dividing. Yeah, let's try to run it. Yep, so these last two digits will be removed from the right and placed to the left. Let's try to do it with some other value of rotated times. Let's try to have this and then be rotated by 4 times. Let's see. So 4 times is 2984, 2984 and then 56. Yep, that is right. So let's consider if k is negative now. So what will happen if k is negative now, right? If k is negative, let's say if k is minus 2, what we have to do is we have to take these numbers that we have, and then we have to put a 5 6 in front. Okay, so how will we do that, right? What we can do is that we can have division of the numbers first, and we can also have modulus of the numbers in the same way. Yeah, but we have to write an if condition, and then we'll have to deal with those two separate scenarios for if k is negative and if k is positive. So let's say I deal with this scenario as like we'll require the digit count in either case. So this is the scenario when k is greater than 0, right? And that is where we will keep the int rotated number as by k we mean times here, right? Yep. Yep. And we'll consider that we don't get the times as 0 here, because if the times is 0, then we don't have to do anything with the number. We just have to print the number as it is without any rotation. So let's assume that we don't get times the value of times variable as 0, right? So we'll get these values as well here. But what we have to do now is that if k is less than 0, what we do is we we have to get the first two digits as mod num. Okay, so how will we get that? We'll get those by digits plus k. So what is the digit count? 1 2 3 4 5 6 is the digits count, right? 6 minus 2 is equals to 4. Okay, so what we'll have to do is that we will have to divide by 4 to get 56, and then we will have to do the mod to get the new number, mod 4 to get the new number, right? So we'll have to divide now to get 56. The time should be minus times here, right? Because minus of minus is plus. So we'll get 10 to the power minus of minus 2, let's see, which will be plus 2, right? Similar is the case here. And then what we can do is we can have mod num. What will we have the num? Mod num is this one, right, for now, right? So we'll have this number, 2984. What will be this number stored in? Let's check that now. It will be stored in temp num, right? Okay, we have both. Mod num is this and temp num is this. Temp num into, we have to do temp num times now. Right. What we have to do is 10 to the power digit count minus times. Okay, what will be the thing is digit count is this, right? 1 2 3 4 5 6 6 minus 2 is 4. Okay, so we'll we'll have to do 10 to the power times, right? That to minus times plus mod num. So what we do here is we take this number which we get by taking modulus, which is the temp number here. Okay, temp number we get using modulus. This we get using division. Okay, okay. So the temp number we get is using modulus, which we get using 10 to the power, which we 10 to the power digit count minus 1, right? Digit count plus times plus times. And how do we get this number? In a similar way. Okay, and what if times? Okay, times is minus 2. So first we get mod num by dividing temp num by 10 to the power digit count plus times. Digit count is 6 plus 2 plus of minus 2 is 4. So we get 56 as mod num. Then we get 2984 as num, right? And then what we do is that we take this 2984 times 100 because the times is 2, right? So 10 to the power 2 plus 56 plus mod num. Yep. Then we get the rotated number. So let's try to run this for a negative scenario. Oops, sorry, I ran it for the positive one again. So what will happen is these two digits should come here. So the new number will be 298456. 298456. Let's try it for another value. Let's see, minus 3. 984 and then 5624. Yes. So what will be the time complexity for this? So the time complexity for this will be of the number of digits in the particular number. So if you have three digits in the number, the time complexity will be O of 3, right? So we have solved the problem of the Leo. I think that will be all for today. See you guys in the next video.